All right, guys, so now we're going to move on to rotations about other fixed points, just meaning other points on the coordinate plane. So like if you look at our example over here, P is the fixed point, and this pre-image ABC is being rotated 90 degrees counterclockwise, all right, and forming this image right there. Okay, so this isn't too terribly difficult, and the rules that we had before, they're still going to apply. So these rules, again, please have them written down so that you can just have them readily available when you're working through problems, okay? Because these rules are going to apply in a little bit different of a way, okay? They're going to apply to the vectors that are kind of formed from the fixed point, okay? So for this, the best way I can say to think about this is you got to know the vectors that are formed. So when I say the vectors that are formed from the fixed point and the pre-image, what I'm saying is, like if you look at our example here, all right, if we're going to write in vector notation, all right, the distance from P to A, okay? So I would count over 2, and that would be my x component, and I would be going up 1, 2, 3. Now, both of these are in a positive direction, so 2 and 3, all right? Again, both in a positive direction, positive x, positive y. So I do those funky little brackets. It kind of looks like a sideways V, and I put in 2, 3. Okay, so that would be the vector that's formed from that fixed point and one of our vertices in the pre-image that we're going to use to rotate. So we're going to use that. So that's just a little review from 9.1 where it did some vector notation. So make sure if you're having trouble with that, look back at the 9.1 notes, okay, with vectors, or join a Zoom session, or shoot me an email, whatever. We can always arrange another Zoom session or anything like that, okay? All right, so moving on, I'm going to pause the video here and just plot the triangle, all right? All right, guys, so there is some steps over here, all right, to help take you through, okay? So I did the first step, all right? We graphed it and found the center of rotation. Now, the next thing, it says write the vectors formed, all right, for step number 2. Write the vectors formed from the center of rotation to each vertex in component form, okay? So all this is we are going along the x-axis, along the y-axis, and moving in those directions. So meaning we're going to move left and right, up and down, and see how long it takes us to get from P to X. So the next thing that I would suggest that you guys do is our center of rotation is P. So we are going to go from P to X. All right, we have that. Looks like a ray, but that means vector PX. We also have PY, vector PY, and vector PZ. Okay, so all you do is you put that center of rotation first, and then you make the vector with every vertex of that figure that we're going to rotate. So what we're doing here to write the vector, we are going to count over how many spaces and count up. So from P to X, we are moving. It's not ready. Okay. So from P to X, we're going to move this direction and up. Okay. So when we do that, we are going 3 over and 1, 2, 3, 5 up. Okay. So the X component, meaning moving along the x-axis or moving left and right, is 3, and then the y component is 5, both in a positive direction. So we leave them as positive values. Okay, so that is for px. Looks like we're going to get cut off, so we'll finish this problem up in the next video.